Sounds good.
All right, so this is session number 2, talking through the Smart App Launch, and I think last time we had also talked a little bit about the relationship between app launch and what we call the backend services specification. So I know you've had a chance to review, Carl. Where should we dig in today?
Yeah, so I've spent, I don't know, a couple hours a day looking at OAuth 2 and trying to internalize Pixie and some of the other linked documents that are mentioned in the IG. And I spent some time looking at the backend services IG that you mentioned at the end of our last call. And so I've sort of internalized some of these concepts, and I've been keeping a document of some of my questions and confusions, and just sort of a journal as I go through this. So maybe at some point I'll revisit that and bring up some of the questions that I've had, but I just wanted to say that I thought that the reviewing the backend services document was helpful, and I wish I had done that before our last call, because I think some of the bits and pieces of how the configuration is done were revealed to me, or at least my understanding solidified after reviewing the backend services guide. So, I mean, it might be helpful for us to just sort of visit that document, and I can sort of say out loud some of the things that I found helpful, or maybe if you had an introduction that you wanted to give to the uninitiated, we could spend a few minutes on this.
Sure. So I think the sort of short introduction on this backend services doc is we developed this as a way for a client to connect to a server in the case when there's no user in the loop. And so it covers kind of a system-to-system trust, where a service can connect directly to a FHIR endpoint. And it's been pre-configured to grant a certain access. And then each time it runs, it can request an access token that will last for a certain period of time. And the sort of authority behind that request, the reason it's allowed to get an access token, is the fact that it has been pre-configured with certain permissions. Now, it's worth saying this guide was developed specifically for that use case where we've got a client connecting to a server with no user in the loop. We're going to be migrating this particular page over into the Smart App Launch specification. So right now it lives as part of the bulk data spec for kind of historical reasons. The time when we were writing this was also the time when we were working on bulk data export. But we'll migrate this page over and provide some of these techniques as a way for backend services to connect, just as they are today. We will also be looking at using this authentication method, which is to say public key authentication, as just an enhanced way for any smart app to authenticate. So a better alternative to shared secrets. So part of the work we'll be taking on is going to be figuring out how to break this web page up into sort of the authentication pieces, which could be used by any smart app, and then the backend services authorization pattern, which really fits for apps where there's no user involved. That's the quick background on it.
Yeah. Yeah, I was I found myself wondering when I was reading through the Smart App Launch spec, is it difficult for apps to maintain a list of, or maybe it's a single authorization server endpoint? And is there an opportunity for the EHR to provide a dynamic list of authorization servers? Or is this just part of the challenge of having an OAuth 2 authentication setup with an app and an EHR?
Yeah. So, I mean, it's worth saying sort of the classic use cases for OAuth 2 would be, or for OAuth in general, would be something like an app connecting to Facebook APIs or Google APIs or Twitter APIs, where there's like only one Facebook out there. And an app connecting to the Facebook API registers with Facebook and then learns about all the different Facebook scopes that it can request and learns about the different Facebook REST APIs or Graph APIs or whatever the flavor of the moment looks like. And then the app can connect to Facebook with a user's permission. And then if the app also wants to connect to Twitter, that's like a different sort of thing. It goes to Twitter and registers a client with Twitter and gets different kinds of scopes, and it's going to call different kinds of APIs. And so there was always a very tight binding between sort of the API surface area and the API provider. And what we're trying to do in SMART is a little bit more flexible or dynamic. The idea being there could be hundreds or thousands of different EHR implementations out there, all sort of hosting an API with the same shape. But an app might have to register separately with the different services, and there's kind of a scalability problem or challenge there. And what we've done in SMART is to really focus on this one-to-one connection between an app and one instance of an EHR running somewhere, and say, if we can't solve that problem, we're stuck. And there may be many different ways to solve the problem of scalable registration. And so we didn't try to tackle that one right out of the box. We said, different vendors can innovate in that space. And so what we've seen is, there's one place in the API where an app is launched. This is in the EHR launch flow that we talked about last time, where the EHR passes a parameter to the app. It says, here's the issuer, here's the FHIR server that you're being launched against. And so the app can be configured to recognize lots of different issuers here. Maybe it's been configured to connect to 5 different sites or 500 sites or 5,000 sites. It would look at this issuer and say, oh, you're talking about http://EHR/FHIR. Oh, I know that server. Let me look up in my database and figure out the client ID to use and the client secret to use based on this issuer. And so the model is definitely that the app has been pre-configured. But in real life, that doesn't necessarily mean that the app developer is going to like one hospital at a time through that process. There are a lot of efficiencies that can be gained. So maybe the best example today is the way that Epic does their registration, where if you're building a patient-facing app in particular, you can register that app once at open.epic, and then you can download a list of FHIR endpoints, which is like available in a JSON file. And actually, this is new. I hadn't seen this one yet, but they also offer it as a FHIR bundle. So let's take a look at that. What that is. So this is a bundle of FHIR endpoint resources. Super cool.
Awesome.
This is actually really nice because the JSON files were pretty limited. It's a little hard to see here, but there's only each entry has just an organization name and a FHIR endpoint URL. And so it can be really difficult if there's something like Mercy. There's a lot of different health systems that have the name Mercy in them, and like how do you tell them all apart? That was sort of persistently one of the challenges of working with this endpoint list JSON file. So my guess is that this FHIR bundle has got a little more metadata. They've got names and organizational IDs, which could be quite helpful.
Cool.
And then some kind of hierarchy even. So you can see that this Brooklyn Hospital Center has a managing organization. And I wonder what this is, if this is something we can find. Well, okay, it's a contained resource. So I see. The endpoint is managed by this organization, and the organization itself is just embedded in here. But this is a great start because it gives you, a lot of the power of the FHIR API for describing some of these things. All of this is out of scope for SMART. We just say a client needs to recognize a FHIR endpoint when it's launched. But these kinds of resources, a bundle of endpoints from a particular vendor, these are super helpful because it means that you can register your app once and connect to hundreds of hospitals and health systems around the US. And so maybe you do that with a few vendors and you start covering most of the territory. That's the basic model here. And the app does need to keep track of the client ID to use for each of those sites. And different vendors make different rules. So in Epic, for example, if you're building a public client, you get just one client ID. But if you're building a confidential client, you get a different secret for every site you connect to, so that one health system doesn't know your secret from another health system. Other vendors make different choices. So I think Cerner's environment, for example, you register once and get a client ID and secret that then can be used across a broad set of health systems that are served by the same kind of cloud infrastructure that Cerner provides. So different approaches from different vendors. We allow for that kind of innovation around how to scale app registration. But at the end of the day, when your app is launched, it recognizes this issuer URL, and it picks out the right client identifier and, if necessary, the right secrets to use to establish a launch.
Awesome. Well, yeah, and I apologize if that question was a bit of a non sequitur, but what I was thinking of in the backend services was how the JSON Web Keys are provided dynamically. And I was just wondering if there was an opportunity or if there was an intent to, provide an analogous setup on the other side.
So what we say when a client registers for backend services access is it needs to somehow register a public key with that server. And we say that that's done in the form of a JSON Web Key set. That can either be the client just provides the key set directly to the server, like pasting in a snippet of JSON into the registration portal. Or it can be registering a URL to a JSON Web Key set. And this is what we say we strongly prefer or we encourage because it allows the client to then register its keys later on. So that's a pretty powerful technique that opens up when you've got asymmetric keys available to you, because it's a safe thing to do to publish your public key, and there's standardized formats like the JSON Web Key set structure in which to do it. So once we move this page over to the Smart App Launch spec, and this becomes a valid method of client authentication for user-facing apps, then all this functionality will come along with it. And it doesn't mean that you can do your entire registration this way, but at least you can register your secret or your keys in this fashion that's kind of dynamic or later binding. And that's a really nice capability.
Yeah. Are there any restrictions on the domain that serves the key set?
I mean, the EHR might establish some restrictions, although it's a little difficult to imagine what they would be in the general case. We basically just say the EHR needs to offer some kind of registration process. The EHR will get a client ID and a public key. And I actually think the language here is a little confusing because we say the client shall register its client ID, but in the general case, the client registers and it might receive a client ID from the server. It tells the server what its key is, but the server might be responsible for assigning this ID. It's the only way to prevent clashes.
Cool. Okay. So looking back at the app launch, I guess I just wanted to take a minute and look at not this launch sequence, but the other one.
The standalone sequence?
Yeah. So in some of my scribbles, I had written, what is this code? And later if you scroll down a little bit, right. So like in the redirect back from the auth server to the app, for some reason, what I'm thinking of is off screen. But
sorry. So the redirect, just to orient ourselves, the app sends the user over to the authorize endpoint.
Yep.
That's a redirect that happens in the web browser from the app to the EHR. And then the user would potentially authenticate, would potentially say like, yes, I agree. And then the result is returned back to the app by redirecting back to the app's redirect URI. And so that's what we're looking at here. That's a redirect that happens in the browser where two parameters are passed to the app.
And that's part of the OAuth protocol. That's just
this is
OAuth.
This is bog standard OAuth 2.
Yep. Now the authorization, that's when before that code is returned in a redirect, the scopes are parsed and evaluated for whether or not the requester has authorization. Is that right?
Yeah, I mean, by the time this code is returned to the app, this code represents an authorization grant. So this is saying, the combination of the end user and the EHR have gotten together and reviewed the request and given it a thumbs up in some form. It doesn't mean the app has gotten everything it asked for, but it means it's getting something. Like it's going to be considered a successful authorization.
I guess what's still unclear to me is if the app is requesting access that it doesn't already have access to, how is the user involved in the resolution of that?
So the answer here can be a little subtle. Formally speaking, some combination of the user and the authorization server will act together to approve a request. And how much of that job is on the user and how much of it is on the authorization server kind of depends on the scenario. So for a patient-facing app, it's basically entirely on the user. Like the patient is saying, yes, I want to connect this app to my records. Yes, I'm willing to grant these 3 scopes and I'm unwilling to grant these 2. It's basically up to the patient. There's nobody else with the authority to say no if the patient wants to say yes. But if you're looking at a provider-facing app, in that very same scenario, where the app redirects to the authorized endpoint, oftentimes that provider is not going to have to see or do anything. There's just going to be a policy in place that says when somebody who's working as a practitioner at this hospital goes to launch these 7 pre-approved apps, they'll just be automatically approved, and these scopes will be granted and these scopes won't, and the user might not have to make any choice because they're working in the context of a role at an organization that has a policy in place already for them. And so at the formal level of the spec, we don't get into the details about exactly who or what is responsible for doing the approval. We just say, here's what a request looks like, here's what it looks like to deny it, and here's what it looks like to approve it. And then how it happens is a black box.
Okay. All right, so approval happens, a redirect back to the app redirect URI happens, inserting the code. Now at that point, the code can be exchanged for a token. Is there a separate like token server, or is it the same authorization server?
Yeah, so we don't get into details about servers as much as we do about endpoints. And so if we look at the discovery data, here's what a server advertises. A server will say, I'll just look at the example. A server will say, here's my authorization endpoint, here's my token endpoint. So those are 2 endpoints. They might happen to both be hosted on the same domain or not, but they are definitely both listed in this discovery document. And so a client knows I start here. Once I get a code, I can use it here.
Okay.
And the general premise is, in OAuth too, you talk to the token endpoint once you have an authorization grant. And what that means is like a decision has been made by the time you're going to sort of talk to the token endpoint, and you're just going to get a token based on that decision. And so that could be the example of an authorization code that we've been looking at here. That's a really common case for user-facing apps. The user makes a decision. That decision is sort of returned in the form of a code, and then that code can be used to fetch a token. That's a very common flow. For backend services, an app can just talk to the token endpoint directly because the decision has been pre-configured in the authorization server. They don't have to go anywhere or get permission first. The app just connects to the token endpoint and says, I need a token by virtue of the fact that I am client X. Here's a signed statement to prove it. Here's the scopes I need. Thank you. And then that's a request where the authority to make the request comes from the fact that the client can authenticate. And so that's the generic kind of term that OAuth 2 uses, is to get a token, you need some kind of authorization grant.
And then once that has been granted, in the app launch diagram, the communication continues between the app and the auth server, or is the token enough to communicate with the fire server, and the auth server is sort of only needed when the token is about to expire?
Yeah, that's basically the model. Once you get an access token, that's all you need to make Fire API requests. Now, under the hood, when you use that access token to say fetch patient 123, the resource server is responsible for looking at the token and deciding whether you're allowed to see patient 123 or not. Oftentimes what happens is the resource server under the covers will go back to the authorization server or some other internal database and say, oh, I just got this request with this access token. What's it good for? And so oftentimes the resource server will be talking to the authorization server under the covers, but from the app's perspective, that's a black box. It's talking to the resource server. The resource server is responsible for giving it the right stuff.
Okay, cool. But I think when I first read through the flow, I thought, okay, well, there's an authorization step happening and then an authentication step happening, and to me that seemed backwards. But now I understand, there's, a token has to be authenticated whenever it's used, and the authorization happens before the token is handed out.
So the authorization definitely happens before the token is handed out. When you say authentication when the token is used, tell me more about what you mean by this.
Well, I guess I imagine if there were a rogue actor who was attempting to access the Fire API, they might try and craft an unauthentic token and pass it, or maybe they've stolen one somehow, or there has to be authentication happening after the authorization happens.
You mean like at the time that you connect to the resource server?
Yeah.
Well, I mean, this is...
Well, yeah, I guess they're separate, and I thought that they were combined. The authentication, the authorization happens in order to get a token, and then there's a separate cycle of communication that happens from that point. And then using that token has to be authenticated. And like you said, there may be some background authorization happening between the Fire resource server and the auth server, but that's sort of invisible. I think in my mind, when I was reading through this document, it sort of struck me as odd that authentication wouldn't happen before authorization.
So I think we need to be more precise in the terms we're using here. We should say, anytime we're saying authentication, we should be saying authentication of what and to what. So let me see if I can walk through this flow and talk about. Let me start by telling the story where there's no OpenID Connect going on here. So OpenID Connect is a authentication protocol that helps an app to authenticate an end user so that it knows which person the end user is. I'm going to leave that off to the side for a sec. So let's just say this is an app where it doesn't care who the end user is. We can layer that back on in a minute. So this is the regular OAuth 2 flow. So ultimately what the app is looking for is the app wants to be authorized to access some data. So we say, the app is requesting authorization at the beginning here. It's requesting authorization from the EHR authorization server. And typically, for a patient-facing app, the EHR authorization server is going to help the patient make that decision. So typically what will happen here is we say, this step, when the redirect happens to the EHR authorization server, we say this step may include end user authentication, which is to say the user may be asked to authenticate to the EHR's authorization server. So it knows, before it says, hey, do you want to approve this app? It has to know that you are Carl and that you have the right to approve this app. So there could be a user authentication step that happens here in order to allow the user to authorize the app. Does that make sense so far?
I think so. Yeah. So it would be like do you want to approve app so-and-so to access your vitals? Or
yeah. And before you get to that do you want to approve step, you might have to sign in.
Okay.
Or if you're already signed in, you might have to re-authenticate. Or, different sites use different kinds of techniques here to sort of elevate the level of trust. Totally up to the authorization server to decide what kind of user authentication it wants to perform at this step, but there's usually something. At the very least, there's an active session cookie in your browser, and the authorization server sees that and says, you're still signed in as Carl. Great. So there's this user authentication step that often happens here. Now the app is authorized, right? It gets this authorization code. It trades it in for a token. This step here, where it trades the code in for a token, this step might or might not include an authentication of the client. So in the case of a public client, it doesn't. The client is just saying, I got this code. I'm a public client. Let me have an access token, please. And that's fine. In the case of a confidential client, this request would be accompanied by some kind of client authentication. Either the client would include a secret or a signed assertion demonstrating proof that it holds a private key. But for confidential clients, there would be some kind of authentication attached to this request to say, not only do I have this code, but I can demonstrate which client I am, and the combination of those two things is what will give me an access token. Does that make sense?
I think so. And the a confidential client is one that can, essentially has like a TPM or some device that, can keep a secret that can't be discovered through inspection. Like a single page app could be, you can open the debugger and figure out, okay, there's a secret hidden in here.
Yeah, and I mean, the sort of classic case to think about for a confidential client is a server-side web app, where it doesn't necessarily need a TPM. It's just running on a machine somewhere that the user can't see.
Okay. We
get into some interesting edge cases or maybe gray areas when you think about an app running on a user's device where the key itself is stored in the TPM, and there's some guarantees that you can get in that situation. But it doesn't fall super cleanly along the public client, confidential client lines that OAuth originally envisioned. These are kind of new considerations that you can think carefully about in the context of modern web apps. But I think it's good to build up an intuition starting from the use cases that OAuth 2 was designed for. So the canonical examples to keep in mind are like a server-side web app running in the cloud somewhere, running under somebody's desk on a server that's well separated from the user. That's sort of the classic confidential client. Or on the public client side, just think about a single-page web app that is just running in your browser or on your phone, like a native mobile app that's not trying to manage a secret of any kind. Those are the sort of two endpoints of the classic OAuth spectrum. And over time, we have some other more interesting points along that spectrum.
So in the case of a confidential client, they can use their secret. Like you said, there could be like a signed bit of data that says, I control a secret, and there's the proof of it. I guess I'm still not clear in the non-confidential client, or the
public client.
The public client, what's the additional proof that they provide?
There is no additional proof. For a public client, ultimately the security rests in the fact that the client was able to receive this redirect here.
Okay.
And this is this is either a TLS URL, like https://myapp.com, or in some cases it could be a custom URL scheme on a mobile device. But the security for public clients comes from the fact that this app, and presumably nobody else, no threat actors, is able to receive a redirect at this URL.
Okay, and that code that's returned is the extra secret.
I mean, the code just encapsulates the fact that authorization has been granted. The idea is you want the token endpoint to have this sort of simple job of checking some kind of authorization grant and issuing a token in accordance with it. So think of the token endpoint as a purely API thing. In order to get that grant in the first place, you need some kind of UX, user experience interaction thing. And so to let the token endpoint's job be straightforward, we add an authorization endpoint as a prior step. That captures all the user interaction pieces, and we return this code to the client that it can then trade in for a token. The same pattern is particularly useful for confidential clients where you don't want to send the access token into the browser. But this redirect happens in the browser. And so by passing along a code, it lets you get the client what it needs without exposing the end result to the browser or to the user. That's part of why this separation exists. For public clients, that separation is less important, but having one flow with one set of steps and one set of parameters is really, really valuable. And so that's why we use this flow for public clients as well as for confidential clients. Early on in OAuth, there was something called an implicit grant, which was sort of, hey, actually, it would be okay if we just returned a token here. For public clients, they do fine. And that's like technically true, but there's just a ton of ways to get it wrong. So it's a different flow and opens you up to a bunch of kind of subtle bugs. And so what we said in SMART is we're not going to use that implicit grant. And since then, that's actually become the prevailing wisdom in OAuth. The implicit grant is sort of left off of your best security practice list. And we've basically said, use this authorization code for any user-facing app, public client or confidential client.
Okay. And then can you say why the that second is a post? Yeah, that second communication is a post.
Instead of like a get?
Yeah. Is it just to prevent things from appearing in URLs or?
Yeah, I think that's fair to say. There's value in specifying something, and post gives you an opportunity for a longer message body than a get. And let's say by default, servers are configured to log post bodies much more conservatively than they are to log get URLs. So those are all things that sort of push the OAuth spec towards using post here. The other point, just from HTTP semantics, is when you look at this operation, you're affecting state on the server. You're trading in this code for a token, and you don't get to do that twice. Like the semantics are, you spend that code and get the token out of the machine. And so using a post is preferable for those kinds of semantics that are going to, change state on the server, not give you an idempotent request that you could repeat. All that pushes you to post. So we were looking at authorization and authentication. We said this overall thing is an authorization flow. There could be a user authentication step here if it's needed. There could be a client authentication step here if it's needed, where the client authenticates to the authorization server. Once the client gets an access token, that access token is a bearer token, which is to say, whoever holds it can use it. That has some really nice properties, like it's very simple to work with. You get the token, you can store it where you need to store it, you can ship it where it needs to go. Very straightforward to work with. It does have some downsides, like if somebody steals that access token, they can use it just the same way you could have used it, and there's no telling, really. So the best way to think about the access token is it's a bearer token, whoever holds it can use it. There's no authentication required to use an access token to fetch data from a server. The access token represents the fact that you're authorized to make that request. In real life, the FIDO resource server could have some additional policies or threat detection turned on, right? Like, maybe it's looking at IP ranges and it knows this client only ever connects from North America, and it associates the access tokens with that client, and it has anomaly detection to see like, oh, what's going on? Why is there a request happening suddenly from another country? Like maybe the authorization server is going to tell the resource server like, wait, hold off, like let's maybe cancel this thing. But all of that kind of stuff is out of scope for the spec, right? That's like special sauce server behavior. From the OAuth perspective, access tokens are bearer tokens. Is that fair?
Yeah, no, that's helpful. I guess I also wanted to ask about where does Pixie come into this, and is Pixie more relevant for one flavor of client than another?
So the short answer is in in the spec that we're planning to publish for Smart v2, we introduced support for Pixie, and what I think we'll have agreement on, we have to wait until the block vote next week, but I think we're going to have agreement on language that's even stronger than what's written here. So what we wrote at the time of the ballot was, we recommend Pixie for all clients, so we say should. And we say public clients shall use it. And that left this kind of gap where, like, if you're a confidential client, you should use it, but maybe you don't have to. And based on the ballot comments that we got, we're actually going to crank this up and just say all smart apps shall support Pixie. Public client, confidential client, doesn't matter. So what is this? Why does it matter? It's worth reading through the Pixie spec, but this was originally designed to solve some issues with public clients, but it turns out to provide some better security properties even for confidential clients, even though that wasn't the driving design consideration. The basic intuition on Pixie is, like, imagine that you've got an OAuth launch happening, just according to this diagram we've been using. And let's see if I can. Oh, I'm playing too many games with Windows ISIS. So imagine you've got your regular OAuth launch going on, and of course, now that I finally got this picture open, it's not the picture I wanted. All right, that was fetching data from the Fire server, but I just wanted the diagram that was showing the actual OAuth launch itself. So this is our basic OAuth flow that we've been looking at. Imagine that my app is a native app on my mobile phone. It's the growth chart app, and its redirect URI is like a custom URI scheme. So instead of being a TLS URL, it's going to be like growth chart : / draw a plot. Like, let's say that's its redirect URL. Now, if you imagine this app requests authorization, the user maybe gets redirected into a web browser context where they sign in, they grant authorization, and now we redirect back to the app. Imagine there's like a second app on my phone, a malicious app, that is able to intercept this growth chart redirect URL. And so instead of that authorization code being sent to the right app, it's now being sent to a malicious app. If we just follow this diagram, the malicious app now has an authorization code. It's a public client, so it doesn't have to authenticate. So it can just go ahead and trade that in for an access token. And now the malicious app has an access token and can do whatever it wants. So that's the threat that Pixie tries to mitigate. It's a pretty limited threat because there's a slightly worse case where this malicious app is like running as root on your phone. And if the malicious app is running on your phone as root, it's game over. Like, it doesn't matter what you do. The malicious app can just wait until the real app gets an access token and then steal it. So that's not really something you can mitigate against. But if your threat model is like, I've got this malicious app, it knows how to subscribe to a specific redirect URL, it can't inspect the memory of the good app or, pry into the state of the good app, but it can intercept these URLs. If that's your threat model, then there's sort of a neat thing you can do to prevent that particular threat.
Okay.
That's what Pixie is.
So if, to pick on my mom, if she grants, access to these type of URLs to this other app that she installed, then, that's the threat model. If she then tries to use, her phone to look at her health chart and launch an app that would access her EHR, then okay.
Yeah. Now, and if your mom's in that situation and then she opens up the bad app directly, now the bad app can just start an OAuth request, right? And if she says, "Oh, sure, I want to grant it," like, that's also not a threat that we can mitigate. But if she installs the bad app without realizing it and then uses the good app to request access, we can at least prevent the bad app from jumping in right before that flows over and grabbing the code. That's
Okay.
what Pixie does. And it
Okay.
does it pretty simply. It just adds an extra parameter to this original authorize request, which is called a code verifier. It's just basically the app generates a random value and hashes it. And the authorization server keeps track of that hash. So later when the app tries to use the code, the server says, you can't trade that code in unless you tell me the pre-image for that hash in step 1.
I see.
And
Okay.
for the app that generated the hash, that's super easy because it's just the random number that it generated to start. But for an app that didn't have access to that information, it's game over. So that's how Pixie mitigates that particular threat. And that's really what it was designed to do. And that provides some better protection for public clients. If you dig into the details of that, if that app was a confidential client that could actually keep a secret, this protection wouldn't directly seem to matter, because you'd say, well, the malicious app that's intercepted the code wouldn't be able to trade it in here because it wouldn't be able to authenticate in this step. It wouldn't have the client secret or the asymmetric key or whatever that was needed. And that is true. That's why Pixie was mostly designed to solve this public client problem. But there is another thread that where Pixie turns out to be helpful, even for confidential clients. So if you're interested, we can maybe on another call dig into that one. But I don't want to get too deep in the weeds. Just other than to say it's useful for both cases.
Okay. Yeah, and I think we've spent a lot of time looking at this diagram. I think I'd like to go back to the EHR launch, and because I think understanding this, I feel like there's gains by looking at the EHR launch and highlighting the similarities and the differences.
Yeah. So the EHR. So what we're looking at here, what we've been talking through, is the standalone launch. The EHR launch is 100% identical to this. If you start at the bottom and work up, the EHR launch is identical. It has all of these steps. The only difference is the EHR launch has one step at the beginning, which is, in this standalone launch, we started from the app. So the user basically tells the app, I want to launch you now. I want to connect to the EHR. So the trigger for this first step is a user action. In the EHR launch, the trigger for this first step is the EHR opens a window onto the app, opens an iframe or a web browser window onto the app and says, time to launch now. And then we just pick up right at the top. So when we look at the EHR launch, which I'll open up side by side, so this is kind of the abbreviated version of the standalone launch, where we start from the app. This just takes us through the first redirects. So this is what happens in the standalone case. For the EHR launch, there's just one step that happens at the beginning, this one initial step, where the EHR opens a window onto the app and says, time to launch. And then the app proceeds exactly as it does in the case of the standalone launch. So the overall flow is identical, but with this trigger being the EHR opening the app and saying, time to launch now. And if we look at what's involved in that trigger, there's basically 3 things. Actually, it might be easier to see in the table, but this is fine. So there's the app launch URL. That's something that the app registers with the EHR ahead of time. Basically, the app says at registration time, hey, when you want me to launch, open up this URL. Pretty straightforward. It might not be the same as the URL where the app is going to eventually host a web page that shows information to the user. It might be just a URL that's specific to launching, only used for that one purpose. Or it could be a general purpose URL, totally up to the app. So the EHR opens that URL, and it passes in this parameter called the issuer, which is to say which EHR or which Fire server is responsible for issuing this request. This is the Fire server base URL the app's going to connect to. And as we said earlier, this issuer is kind of the key for the app to know, like, hey, where am I going to be connecting to? Which client ID should I be using? The app is going to have some kind of internal database or lookup table where, based on this issuer, it's going to pick out the right client ID and potentially the right secret. So that's a really important parameter. And then there's one other parameter called launch. And the goal here is to make sure we don't lose track of which EHR session started this whole thing. And so the EHR generates this launch value, which is opaque to the app. The app sees it, and it just passes it on through into the next step. But that allows us to tie this whole process together so that at the end of the day, when the app gets an access token, 3 steps later, that access token has the right contextual information from this EHR session. And that all works because the EHR session generates this launch value, the app passes it into the authorization request, and then the authorization server keeps track of it through the rest of the flow. That's the EHR launch. It's one extra step on top.
Great. Well, I think that makes sense, and thanks for visiting that while we still have it fresh. I guess I've been using my, and not to be unfair to other EHRs, but I've been using my MyChart recently, and it had me wondering, like, is this EHR-like enough that there could be an EHR launch from within a user or patient portal like that?
Yes.
Is that kind of where this might be hopefully going, or is that still going to be a separate but important use case?
So these standards, the Smart App Launch, can absolutely be used in that way. So the EHR session here, classically, the thing I have in mind is a provider sitting in front of their EHR with a patient chart open. But just as easily, this could be you sitting in front of a tethered PHR like MyChart. I'm sure that's not exactly the right term of art, but a health record that's offered to you by your healthcare provider that's connected to a FHIR server, that could just as easily be like your MyChart session. So in a scenario where your healthcare provider wanted to offer you some list of apps that you could run from inside of MyChart or launch from inside of MyChart, this EHR launch works perfectly well. In practice, we don't see that a lot. I think maybe we will see it more in the future, but there's probably 2 reasons why we don't see it a lot today. One is it's just not that common for providers to recommend apps to individuals. Mostly what happens today is individuals bring their own app to the table. And so in that case, the standalone launch is a better fit because the EHR launch requires the provider to know about the app and recommend it to you at the right point in the workflow. Whereas for most patient apps today, it's like the patient is making the choice to use the app, and so they start from the app. That's one challenge. The other reason maybe why it's not that common today to see this kind of flow attached to a patient portal is for the places where a provider really wants to offer you a service. Maybe they're going to integrate with a radiology service or a diabetes management service or something. I think they tend to just do a deeper integration. They'll do a backend integration with that provider and then stick the data right into the portal rather than launching an app from the portal. My guess is that tends to provide more of a controlled experience. So I think we see more of that today.
Okay. Awesome. Well, we are almost at time, and I've got about 3% left on my battery. Apparently, Jitsi has been just consuming a lot of energy. What should we start thinking about for the next session, or where would you recommend I go next?
So we've got time blocked off later this week to at least do a preliminary kind of surgery on the backend services spec. So I would say for sure finish reading through this doc. And I would say it's worth cracking open the Smart App Launcher. So in our team GitHub, we've got the our Smart App Launcher where we've been working on Smart V2 features. And there's an issue in here that talks about supporting client authentication. So it's worth reading through this one, at least as sort of a quick view about what could be involved. and looking through the launcher and starting to orient yourself with where some of this functionality lives, I think that would be good pre-work, because having that picture in your head sort of the generic building block in OAuth for client auth, however it happens, whether it's shared secrets or asymmetric secrets, there's this kind of auth concept. That would be good prep for our deep dive next time into sort of refactoring this backend services page.
Cool. Well, I'm at 1%.
All right.
It's
Good
going
deal.
that quick. So.
Let's see you,
Good forcing function. All right.
Take
Thanks,
care.
Josh.